This is store reslet. It's our implementation of Mo with boxes, implemented using that reslet form, so it's a little bit easier to read. We can take this implementation and we can run some direct tests or some experiments if we want to. I could do interp of parse box 5 in the empty environment and the empty store. And what we'll get back, this is what you should expect, is a box allocated at location 1, where the store now has a cell mapping 1 to the value 5. So we could do that. Of course, we could unbox as well. And we will get back in V5 the same store, because unboxing doesn't change the store or make it go away. It just pulled the 5 out of that. I'm going to give myself a little more room here. Let's try another example where I change the box 5 to be just X. Now, if I run like this, of course, we'll get that X is undefined, but I can change that by adjusting the environment that I start with to have extend env bind X to be something, starting with the empty environment. That is, because I'm calling interp, I get to pick the environment. I can start out kind of in the middle of a program where X is already bound. And in this case, I'm going to bind X to a box V1. That is, I'm going to say X refers to a box. Now at this point I have a different kind of problem because 1 is not allocated in my store, but I can change it to, well, not extend m, but override store to have the cell 1 mapped to, say, int b6, extending the empty store, and when I run this, I get back a 6. So I'm starting in the middle of a program that has already let X somehow to be a box that was previously allocated at location 1 with initial value 6. I can jump into the middle there. I can even change this to change the value inside the store to be just box V again, mapping to the same box. So here I've created a store that represents a box pointing at itself. And if I unbox, then I will just get the same box back. In fact, I can keep adding unboxes here, because every time I unbox, based on what's in the store, I keep getting the same box back, and I can keep unboxing that same box. Now, I could have created the same scenario here by a more complicated initial expression that uses let and setbox and so on, but it's interesting and often useful that you can jump into the middle of a program evaluation because we get to pass in the environment and store to interpret all the information that interpret needs to run has to be passed into it, and we get to pick that information to be whatever we want it to be.